In this video, we're going to introduce exponential functions, their key parts, some of the ways that their graphs could look, and then we're going to actually write an exponential function. So an exponential function, in specific, what that means is that the input variable is actually an exponent. So if you notice in these two functions, f of x equals k times a to the x, our input variable x is an exponent. And same thing here, this is just another notation for the same function. It's a raised to a power of t. That t variable will be our input. So let's look at the key parts to this function. The first one is this k or p naught. Those represent whatever our initial value is. So that first number, that's going to represent our initial value. The a value, that's going to be what we call a growth or decay factor. Alright, so what happens with that a value? What determines if it's growth? Well, if a is greater than 1, we'll get some type of growth function. And its curve will actually take on a shape similar to this. And remember, previously we talked about p naught or k being that initial value. That value will correspond to actually be the y-intercept. If a is less than 1, then what will happen is we'll actually get a function that models exponential decay. And it'll take on a shape more in this manner. And again, where k is the initial value, which is essentially the same thing as saying the y-intercept. So we want to keep that in mind. Or we could call that the vertical intercept. Alright, so let's look at a function and see how these exponential functions actually work or behave. So what we're going to do is we're going to plug in some different x values, and we're going to look at what happens. So we're going to plug in 0, 1, 2, and I know I don't have the column here, but we're actually going to add a 3. So we're going to plug in these 4 values. So let's say we plug in 0. This would be 3 times 2 to the 0 power. And we know we're following order of operations. So 2 to the 0 power, well, anything to the 0 power is actually 1. So this is 1 times 3 is 3. So that gives us a point 0, 3. If we plug in 1, this would be 3 times 2 to the first power. 2 to the first power is 2. Times 3 is actually 6. So that's a coordinate 1, 6. If we plug in 2, 3 times 2 squared. 2 squared would be 4. Times 3 is 12. So 2 comma 12. And like I said, we're going to add this column here. If I was to plug in 3 times 2 cubed would be 2 cubed is 8 times 3 is 24. This is a point 3 comma 24. Alright, so we're going to sketch a graph of these points and see how this function is behaving. So we're going to let this be our input, and this is going to represent our outputs. And so we're only going to 3, so we don't need to put too many inputs here. 1, 2, and 3. And if you notice, our outputs are going from 3 to 24. So I'm going to scale the x-axis, or sorry, excuse me, I'm going to scale the f of x-axis. Let's say this is 5, 10, 15, 20, 25, and 30. And so my first point, 0, 3, that represents my initial value. Then we've got the point 1, 6, 2, 12, and 3, we're all the way up to 24. And so you can see we're getting similar to how we previously talked about this shape. And when we think, why are we getting that shape? Well, first of all, we know our y-intercept should have been 3. That's coming from this point here. And remember how we previously talked about that k value, 3, being the initial value. The other thing we should notice is this is obviously a growth function. And the reason that this is growth is that a equals 2. And so since 2 is a value greater than 1, we would expect the function to be modeling growth. Alright, so the last thing we really want to be able to do in this section is to somehow write an exponential formula looking at some graphs or looking at some different points. So we're going to look at A first, and obviously we see this should be modeling some type of growth. So we would expect A to be a number greater than 1. So if we want to write some function, f of t, just instead of f of x, we're going to write f of t. F of t will equal k times a to some power of t. And so the things that we need are k and a. Well, what do we know so far? Well, this point right here would represent our initial value, so we know that that's actually k. F of t equals 500 times a to the power of t. And we somehow need to go ahead and find a. So here's what we're going to do. We're going to use this fact right here, that this is a t and an f of t. And we're going to plug that in and work backwards. So we're going to let f of t be 2,000. And that would equal 500 times a to the third power. Because I'm plugging in 3 for t. And so we want to solve this equation. So we're going to divide by 500. So a cubed equals 4. And so we're looking for some a cubed, or a times a times a, to give us 4. And what you're going to need to do is look at that TI-84 video about solving radicals to find this. But what we're going to do is we're going to take the cube root. And so a equals, to 3 decimal places, 1.587. And so now we have everything we need to write this function. If I plug a in, f of t equals 500 times 1.587 to the power of t. And that would be our function. And notice how a is a value greater than 1. This is showing our growth. All right, here we're expecting on the right for b, we should be expecting a to be a value less than 1. And again, we're trying to write some f of t. So f of t equals k a to the t. Here, our initial value is 30. So f of t equals 30 a to the t. Similar to what we did before, we're going to use the fact that this is a point. This is a t, comma, f of t. And we're going to plug that in and work backwards to find a. So the f of t is 6. 6 equals 30 times a, and for t, we're going to put in 25. We divide by 30. And we get 0.2 equals a to the 25th. And like we did before, we need to use that root. So you're going to need to use your TI calculator. And we're going to do the 25th root of 0.2. And that tells us a equals 0.938. So again, we get a number less than 1, like we'd expect because this is decay. And so the function is f of t equals 30 times 0.938 to the power of t. And so at this time, I would really recommend you watch that video about how to use the TI-84 so that you learn how to take these roots that are not your traditional square roots.